A certain brand of refrigerator has useful life that is normal with mean 10 and standard deviation 3. The useful lives of these refrigerators are independent. Calculate the probability that the total useful life of two randomly selected refrigerators will exceed 1.9 times the useful life of a third randomly selected refrigerator. So let their lives be X, Y, and Z. There are three of them. And we have to find the probability that the useful life, the sum of useful life of two of them, the total useful life means the sum of the two lives. So X plus Y is greater than 1.9 times the third. So X plus Y is greater than 1.9 Z. And if you bring everything over to the left side, as you will soon see why, you get probability X plus Y minus 1.9 Z is greater than 0. And the reason why we brought it over is that we want to call this X plus Y minus 1.9 Z as a single variable. So let's call it W. And that would mean that we have to find probability W greater than 0. So this is the way that we can handle this. Now, X, Y, and Z are all independent normal variables. And we know that for independent normal variables, if you take any linear combination of them, then that linear combination is also a normal. A linear combination means that if X, Y, and Z are the three variables, so you are considering something of the form ax plus by plus cz, where a, b, c could be any constants. So W is normal. And then for independent variables, if we have a linear combination, so now that this, what I'm going to say next, doesn't apply just to normal independent variables, but it applies to any independent variables x, y, z. If you take their linear combination, then the mean of the linear combination is a times mean of x plus b times mean of y plus c times mean of z. And the variance of the linear combination is a square variance x plus b square variance y plus c square variance z. So in this case, the linear combination we are considering is this one, x plus y minus 1.9 z, which is w. So the mean of w will be the mean of x plus mean of y, because a and b are 1 in this case, minus 1.9 mean of z, mean of x plus mean of y minus 1.9 mean of z, and the means of all x, y, z are 10 as given in the problem. So 10 plus 10 minus 1.9 times 10 equals 1. And so the variance of W will be, again, a square variance x. A is 1, so it would just be variance x. The standard deviation was given to be 3, so the variance will be 3 square. Similarly, variance of y will be 3 square. And then 1.9 squared. So note that even if this is a negative constant, so you will write it as plus. So if you use this formula, you're writing it as plus c square. So you'll have plus negative 1.9 whole square. So it becomes positive. So 1.9 square variance of z. And variance of z is also 3 square, because standard deviations of all of them are 3. So this ends up being 50.49, and for the normal calculation, we need the standard deviation. So that'd be the square root of variance. So square root of 50.49 is 7.106. So now, since we have to find probability W greater than 0, so it means we have to change this 0 into z-score. So the z for that would be 0 minus the mean of W over standard deviation of W, which we calculated to be 1 and 7.106. So it ends up being negative 0.14. So probability W greater than 0 equals probability Z greater than negative 0.14. So note that this is a lowercase z, which is for the z-score. That is different from the uppercase Z, which we are using in this problem for the lifetime of the third refrigerator. So z greater than negative 0.14 is the same as z less than 0.14 by symmetry of normal distribution. And from the table, if you look for the 0.14, you see 0.14, you get 0.5557. And all the answers are 3 decimal places, so this rounds to 0.556. So that is choice C.